the man, the myth, the legend, Mr. JR, teaching Disco 45S. Today is going to be teaching us about matrices. Are you ready? I can't hear you.
Woo! Oh, this single clap. Thank you, guys. All right. Matrices. So what we're going to do today, guys, is we are going to put numbers in a box. So that's all a matrix is. You get a big set of square brackets. That's the box. You put some numbers in there. And that makes a matrix. This would be a 3x2 matrix. So it has rows. We say the rows are going this way. And we call the columns this way. So this one has 3 rows and 2 columns. I always remember which way the columns go because I think of a building with columns, and I've never seen a building with columns that go horizontal. But rows might be hard to figure out. Maybe the rows are going this way or that way, not sure. So these are your columns here. Woo! And we have 2 of them. So you can put numbers in there, and then we're going to do a whole bunch of math with these matrices. The reason we introduce matrices is to organize our data. So for example, one of the things that we're going to be doing is taking our systems of equations so let's say I just make up a system of equations. Later we're going to organize this in a matrix, and part of what matrices do is they organize your data, but they also let you write less stuff so you can hopefully do things quicker. So when you create a matrix for this system of equations, instead of writing the x's and the y's, you're just going to write the numbers in front and assume that someone will know that there was an x first and a y second. And then instead of an equal sign, we might just write a straight line because that would be quicker, because that's one line instead of 1, 2, 3, 4 little lines. So you could probably shave off, I don't know, 1/3 of a millisecond by doing that. So for example, we might write that system of equation later as that matrix. And that matrix with the extra line in there, we're going to call that an augmented matrix. But we're going to today, since we're introduced to matrices, learn just a bunch of definitions. So horizontal, those are your rows. The vertical ones are your columns. If you like to highlight things, this would be a wonderful thing to highlight. Rows, columns. Very nice. Now, we describe a matrix by its size, and its size is its dimensions, and we use the rows and the columns to describe that. So the one that I made before, this is a 3x2 matrix. So the thing that's hard to remember is, do we count how many rows are first, or do we count how many columns are first? Well, I have just the thing to help you remember. You can remember because matrices rock. The RO comes for rows first, and then columns next. If you have a CK when you spell columns. If you can't decide whether you want to use the Canadian or the Russian spelling of columns. So what's the size of this one here? This is a 3x4. Matrices rock. Rock. And you'd be amazed, you will remember that. Because it's so simple. So rows always first, columns always second, and that makes that a 3x4 matrix. So sometimes we call it dimension. Here's another word for the size. Sometimes we call it the order of the matrix. So quickly, state how big these ones are. Okay, and Damien, if you're having trouble, I'll give you one more. There we go. That's it. If you get mixed up, always go back to that one. You'll remember, no problem. All right, how did you do? 3 by 1. 4 by 3. 1 by 4. And the toughest one. I always get them mixed up on that one. 2 by 2. One. Yes, you can have a 1 by 1. So when we're talking about matrices, we use capital letters to describe them. So if we wanted to give this matrix a name, we would use a capital letter for that matrix. So here's a capital M for this one, capital P, capital S. You can use any capital letter to describe them. Then when we're talking about the elements within the matrix, we use a little letter for that. So, well, we'll do an example here in a second. Now, sometimes you'll see those entries listed with a comma in between, and sometimes the comma's not there. So this A11 would be the same way of writing this A1 comma 1 if you wanted to do it shorter, if the matrix isn't too big. If you get into really huge matrix, then the comma is nice because you can tell. But usually matrices don't go beyond 9 by 9. So whatever's the first number, that's the row position. And whatever's the second number, that's the column position. So this one right here, A32. Can you see that that's in the third row and in the second column? So that's what the numbers beside it are representing. So if this is matrix A, then we would label all the things little a and then row and then column. This is the main diagonal of the matrix. Okay. So there you go. Find M13, M34, and M24. And then say what the order of that matrix is. You can have a comma or you don't have to. If you want to have that comma in there, but usually if they're small enough, like once you got past 10 by 10, then a comma would be necessary just to know, oh, is that row 1 or row 11? But in this case, it's small enough, you can have the comma or not. Right? If you're a lazy mathematician, if you can avoid writing an extra comma, you will. One, 3, what'd you get? 0. 3, 4. E. 2, 4. Pi. And the order of the matrix? A 3 by 4. Nice. So some more definition. If you have a matrix with only one column, we call that a column matrix. Nice definition. Beautiful definition. If you have a matrix with only one row, we call that a row matrix. Not surprisingly, a square matrix has a certain shape. Yeah, it's a circle. So these are all square matrices because their dimensions are exactly the same. Ooh, what? Oh, that was fancy. Okay. Yeah, so 1 by 1, 2 by 2, 3 by 3, 4 by 4, no problem. A zero matrix has everything inside of it zeros. Because we're going to do math later on, like adding and multiplying. And what happens when you add 0 to something? Nothing. So we need to be able to figure out how we can add 0 with matrices. So we make a 0 matrix where everything is zeros. You can denote it with a bold 0. If you can't bold, you can underline it or something like that. And an identity matrix, now this one is important and different, because if I just didn't show you the definition and said the identity matrix, you'd be like, yeah, I don't know what that is. So an identity matrix is a matrix where the main diagonal is all ones. It's always a square matrix, and all of the other elements are zeros. So your main diagonal here is ones, everything else is zeros. And an identity matrix is always a square matrix. So you can have a 4 by 4, 5 by 5, 6 by 6. Later on, the identity matrix is going to be important because we are going to want to multiply matrices. And what happens when you multiply by 1? Nothing. But it's a little bit more complicated in matrices. Hopefully we'll get to multiplying today, because that's when things get exciting. Ooh, I have a puzzle. Have you seen this puzzle before? So this puzzle comes in 2 different ways. I can think of 2 puzzles with this puzzle. If you've seen this puzzle before, the one puzzle is, can you draw 4 straight lines through all of the points without lifting your pen? Can you figure out a way to do that? And the second puzzle is, you think these are pets. You've got pets in a box, but there's some sort of pet that eats other pets. So you have 9 of them. If you leave them like this in the box, they will eat each other, and that will make you sad. So you have to make fences for the pets. But fences can be only in the shape of a square, and they can be any size square you would like, but you can only put in 2 fences into this box. How many pets will survive? So for example, if you decide that this is your one square and this is your other square, these ones will all eat each other, and you'll be left with only 3 pets. So that wouldn't be good. How many pets can survive? Sure. So if you want to have one fence like this and one fence like this, you will be left with 1, 2, 3, whatever the survivor is in there, and whatever the survivor, 5 pets. But the ones in here will be bigger because they'll be full. Okay? But then you're only left with 5. How many can you be left with? You can make them whatever you would like. Transpose of a matrix is where you take your matrix, you switch all your rows and columns, and then you get your new matrix. So your original matrix here is a 5 by 2. Your transpose will be a 2 by 5. Everything in column 1 now is in row 1. And everything in column 2 is now in row 2. So that is your transpose matrix. So here's B, GT will now be a 2 by 3, A, F, B, E, C, D. Whoop.
Oh, no, I was asking, what is that? What are we going to do with that?
You were going to find out. So the transpose matrices, we don't do a ton of this year with them, but they're just some definitions that come up. But we will be using the identity matrix a fair bit. Now, look at the example. if I add, well, maybe I'll just take this example off for a second and see if you can figure out matrix addition. Okay, use all your brain skills possible. See if you can figure out matrix addition. I'm going to take this one, 1, 2, 3, 4, 5, 6. I'm going to add to it a 5, 3, 7, -1, 6, -5. And it's going to equal, I don't know if you'll be able to figure this out because it is tricky. How do we add matrices? Yeah, I see that blank look. No ideas? You add 1 and this 5. So is that what you're saying? So this 1 and this 5 make this 6, and 2 and 3 make 5, and 2 times 5 make 10. Oh, 4 and 6 make 10, so that's why it's here, because that's the most important spot. 6 and 5 make 11. That's must how, is that what you thought?
It's like spot 1 plus spot 1 plus.
So spot 1 plus spot 1 equals 6?
Yeah.
And 2 and 3 make 5? Does that seems easier than my first way, but I like my first way.
Oh, it doesn't work that way.
No, it works.
Well, not for.
4 and -1 make 3?
I didn't think that was a 4. That looked like a -1.
Oh, it looks, you're making fun of my 4s. Okay, that is a 4.
We're just that good at friends.
Yeah. Right, and this one, this b minus 5 is 1, or is that oh, that's a 6. Okay. Okay. Yes, that is matrix addition. You just take the corresponding spots and add them up. Although I like the other, I guess the hard part about the other way is I was just using the first one, ignoring the second one whatsoever. Yeah, okay. So yes, matrix addition, you just add or subtract the corresponding entries. But now we can only add or subtract matrices if they're the same size or they have the same dimensions or the same order to begin with. So here I have a 3 by 3, adding another 3 by 3, that's allowed. And because it's the same size, you can add it up, no problem. Scalar multiplication. We're going to have two different kinds of multiplication. We're going to have matrix multiplication and scalar multiplication. A scalar is just a number in front. So the word scalar is a math word for number that we often have with a number multiplied in front of something. We often call it a scalar. We use that for vectors and for matrices. So if you have a number in front, this is also very complicated. All that you're going to do is multiply each number inside by that number. And that's based on the same idea you had for multiplying regular numbers. When you were in, when do you learn multiplication, like grade 3? What did they teach you? Wow, 2 times 3. What did 2 times 3 mean? 2 groups of 3. And so it was equal to 3 plus 3. That is annoying. Try that again. So you learned that 2 times 3 was equal to 2 groups of 3. 3 plus 3. The same idea is the same here with a scalar. 2 times this matrix means 2 groups of that matrix. If you did that matrix plus a matrix, can you see 1 plus 1 would be 2. 8 plus 8 would be 16. -3 plus -3 would be -6. And so you're doing the same idea, that you're just saying it's 2 groups of that. And so all we need to do is multiply each element inside the matrix by that scalar. Okay, well, we're not going to take, I'll give you this homework, but are you finding so far It's not bad at all. Okay. Now we're going to have some fun. We're going to do a little activity here. You're going to need your graphing calculators. Okay. You can take some scrap paper out if you like. Everybody have their calculators out and ready? All right, just about got it ready here. In your calculators, oh, nice. I thought I had paused the video while I was making all those adjustments, but I didn't. In your calculators, you are going to put in these 5 matrices, A, B, C, D, and E. So the first job that you have to figure out is how you would do that. And then I want you to do some matrix multiplication. I want you to do A times B and write out the answer. D times B, E times B, B times A, D, A times D, A squared, and C squared. And then write down the answers that you get. So if you want to check some answers, interesting things are happening. Some of them didn't work. And that is how you do matrix multiplication.